Hi, welcome to this Open Security Summit session in December 2022. We have Pete here, which is going to walk us through the latest and greatest of AppMap, which is this really innovative sort of startup that is trying to introduce graphs and maps into how we map applications. There was a presentation that we did a while back with Elizabeth and some of her colleagues, and now we're going to get Pete giving us the updates on the tool and the latest in visualizing. And actually, in this case, doing runtime and code analysis with this really powerful tool. Pete, over to you.
Awesome. Yeah, thanks so much for having me. And yeah, appreciate taking the chance to kind of show off what we've been working on over the last few years or so. So I've got a few slides. Basically, kind of the format of this is kind of a few slides at the beginning to kind of introduce AppMap, myself, what we're doing and what we're building, and then just dive right into the product. We're going to be playing around with a vulnerable Ruby on Rails application. And then we're gonna kind of show you how you can better understand the code using AppMap, finding vulnerabilities in that code, and then fixing them. And we'll be also showing off some of our latest features as well. So let's go ahead and dive in and make sure I can advance my slides. So my name is Pete. You can find me on Twitter at Pete Cheslock. My background has actually mostly been in technical operations for the last many years. Kind of pivoted more recently into the non-engineering side of the house, hung up my pager, kind of get sick of getting paged at 2 a.m. So kind of realized that there's not a lot of 2 a.m. Products presentation emergencies. But all the cool kids call it SRE now. So, but still love that world. I spent a lot of time in observability spaces and the DevOps spaces. And I've worked for some security companies like ThreatStack. They're now F5, kind of core internet infrastructure companies like Dyn, which is now Oracle, and even some more modern data companies like Chaos Search. And now I'm currently working for AppMap, and I've been here for about 6 months or so. So AppMap is an open source runtime code analysis tool. We have over 35,000. This might even be 40,000. The number keeps growing over time. Open source MIT licensed software with Commons clause. And it makes for this data format is open source. It's extensible. Developers continue to extend this. And right now we support a variety of languages. The kind of focus today will be on a Ruby on Rails application, but we do support Java, Spring applications, Python applications, JavaScript applications. And the way that people interact with AppMap is primarily in their code editor. That's where we distribute the software is via there, as well as some libraries that you would include into your source code. And so for the VS Code and JetBrains, IntelliJ, RubyMine users, you can grab AppMap right from the marketplaces. And we'll be showing you VS Code today. We'll be showing you kind of that interaction, and we'll be diving in. So, what are we really talking about today? A lot of developers' time is being wasted on software flaws, whether they're security flaws, whether they're performance issues or maintainability issues. A lot of time is being wasted. And the research shows, $85 billion per year in wasted developer effort just reworking that broken code. And that's when they're able to rework it. A lot of code goes to production broken and is never fixed in many cases. And it's causing a lot of burnout in the developer ecosystem. Devs are burning out from all of this coding rework. These cycles of rework happening is just really dragging on people. And so people try to solve this with code reviews. Humans insert themselves into this and say, if we can do better code reviews, if we can bring some tools in, we can solve this problem. They'll bring in tools maybe early in the process, like static analyzers, but these can't find runtime issues, being able to see the code actually execute, so that it is missing a lot of things. It's also kind of full of false positives. There's a lot of things it may find that are not accurate because, again, it doesn't see the code actually execute. You might actually solve this by just running a DAST in your test environment. This can take a long time to run, to spider through your site, but it also isn't really kind of designed for performance issues, and those can also impact your users in a negative way. So then on the performance side of things, this is where people might bring in tools like APM tools on production, or do kind of third-party pen test or pen testing tools. But this is all happening way too late in the software delivery lifecycle. This is after your users are already impacted. This is after your users have already experienced problems, or from a security standpoint, after you've already had a potentially bad security issues happening. And there's a lot of issues that all of these teams involved in the code review process are, again, hoping that they'll catch as part of this. Many of these you can see with the corresponding CWE number from common weaknesses enumerations, being able to try to catch multiple types of performance issues around N+1 SQL queries, or too many joins exceeding a threshold, or not limiting or filtering on your queries. On the security side, these non-public web requests without applying authentication, common around authorization, preceding authentication, or even something that conceptually seems like a simple problem of finding a secret written to log, but so often we only find secrets written to logs after they're already in our logging platform. And so this is where runtime analysis, if we can see the function handling a secret, and then we see that output of the function being used in a logging library, then we can say with certainty that this is something that's being logged. And being able to capture that before the code is even pushed, even to a development environment, is very powerful. I think one of the most fascinating aspects of these problems is kind of a sign of the times. The design issues are actually the things that are rising in the OWASP top 10. And these, if you kind of think about the state of the tooling right now, it makes a lot of sense that if static analyzers are more common and easy to access, albeit maybe not perfect in their implementation, they're going to capture a lot of the low-hanging fruit and identify it before the code, during a CI/CD process. But again, they can't capture design issues in the code base itself. And so what inevitably happens is that these end up rising in the OWASP top 10. These are the things that we're finding from runtime code analysis, or these are the things that people find maybe when they're already pushed to production, which again, it's too late in the delivery lifecycle. And there's a lot of these anti-patterns that are happening in modern software development. And I think this is even going to get worse as people start using AI-powered tools to generate code for them. They're going to start AI generating code they don't fully understand and copying and pasting that code directly into their projects. And this is just going to end up with a lot of reuse happening without understanding, maintenance issues that will arise from this, and even leading into more complex design anti-patterns like spaghetti code, where it's difficult to extend or optimize or refactor, or where you have just large monoliths that are taking over huge segments of how your application works, and trying to unwind that code into something usable and understandable can be really time consuming to do so. So this is actually one of my favorite kind of cartoons. It's only really half of it, but I think it really speaks for how developers need to page in all of this knowledge into their head around how the code works at runtime. They're basically reading this code and then mentally trying to understand how it would actually execute as they kind of go through the code path, and they have to load it all into their mind. And you can see the bubble is getting bigger and bigger and bigger as this developer loads it in. Of course, the inevitable result of this cartoon is when it someone walks by this person's desk, which is obviously pretty antiquated since not a lot of us are probably in offices right now, but and says, "Oh, hey, did you get that email I sent you?" And it goes poof, right? Because again, they're trying to hold all this in their head instead of having some sort of asset that they can look at, that they can interact with, to give them the same kind of level of understanding. So what AppMap does is we find today's top performance and security issues, most importantly, before they leave the code editor. And that's why we distribute AppMap as a code editor extension, to bring this information as close to the developers as we can while they're actually in the code base. And so what is this data we're even talking about we're talking about all of this deep observability data about how the application is running, like your HTTP server and client requests, including headers and any of the statuses that come along with that, message parameters. We see down into the SQL queries that are happening, being able to show you what are the SQL queries that are being executed from what parts of your code bases, the return values from your functions and whatever parameters you set there. And then, like I mentioned before, we can see when you're logging, what you're logging. If you're logging secrets, we'll see those secrets being generated and being passed around, kind of the flow of data. And most importantly, again, it's an open source project. It's extensible. So as our users continually find new data that they want to understand, they join us in our open source community and extend the data model over time. So for example, some examples that we'll show in this workshop is specific to dynamic security analysis, being able to identify troublesome code within the code editor, and then being able to show how we'll go ahead and fix some of these issues. Again, these are just some examples of different things that AppMap can search for. We'll be using a pretty small set of analyses for our workshop here, but there's a wide list of different things that we're analyzing. And the same thing, these are also extensible as developers find different kind of runtime issues that they're looking for and are important to them. But performance is often a security issue too. Different ways that you could have performance problems that could turn into a DDoS or some sort of service impacting event. Being able to find things like N+1 SQL queries, which are very common in different projects like Rails and Python with the database abstraction libraries that exist. A lot of developers may not actually know they're just adding in a particular function to a page, not realizing that behind the scenes, lots of queries are being fired off. And honestly, in the new world of cloud computing, there's a real monetary cost to these performance issues. And so being able to, again, identify them to developers before they're pushing it even to their development environments is very powerful. They can then fix them while all that memory, all that knowledge about how the code works is in their head, versus pushing it to production and then context switching to some other task. So let's dive in. We're going to talk a little bit today about, as I mentioned, we're going to be working on RailsGoat. This is in the OWASP GitHub repository. There's a variety of different branches that you could check out if you want to play around with older versions of Rails vulnerabilities, like from versions 3 through 6. And what's nice is that it includes an RSpec test suite that we can use, which will essentially fail when you run it because of the vulnerabilities that exist. And as you fix issues, then you can run those tests and it will pass. So for this workshop, we're going to use a forked version of this repository with just some minor updates to some gem files and the README. Primarily just to fix a couple of issues if you're using any of the modern MacBooks, for example, with ARM processors. There's a couple of gems that just need to be adjusted in order to get that to work. So that's the project. That's the project that we're gonna be working inside of our VS Code. So let's dive in. I'm gonna open up my VS Code here. Alrighty, so you can see right here, I've got I'm gonna make this window a little bit bigger. So I've got my VS Code. I've already got this project cloned into my VS Code editor here. You can see it is a Ruby on Rails project, version 6 here. So some of the requirements, if you're going to run this locally, we're actually not going to use Docker for this. So in the README, there'll be some details around how you'll need Ruby, you'll need MySQL, Postgres, various databases to actually run this. You only really need those if you're running it at, like maybe on a server somewhere. For our local purposes, we'll just be using SQLite. It just simplifies just getting this running in general by removing some of that complexity. There is a Docker file within here. So if you're comfortable with Docker, you could just launch this whole thing in a container if you wanted to play around with it. You could always obviously deploy that container elsewhere too if you wanted to play around with it. But we're just going to go ahead and follow these steps here for the most part to get everything installed and and get our project going. So I'm going to open up my my command terminal down here. And you can do that again if you're kind of new to the VS Code world. It's again, I'm on a Mac, so your Windows keys will be a little bit different, but it's the Control tilde key that opens this up. There's also in the top kind of menu bar, you can launch the terminal from up there as well. So the first thing we're going to do is I've already got a Ruby version here. That's kind of one of the main requirements. Like I said, we're not going to need SQL or a database for this because we'll use SQLite, but we will run the bundle install command here. And I'm just going to copy and paste. So I've already ran this command before. This is kind of like we're going to pull the fully baked cake out of the oven here, just so you don't have to wait through all these gem installs. If you do get an error, you'll have to have bundler install. There's some commands that will continue it on. But as long as this command completes successfully, we'll have all our gems that we need to run this application. And we can follow on to the next step, which is creating the SQLite database that we're going to use to actually run this application. So you'll see a couple of new databases get created, one for each of these environments. If you do run into any issues, I did notice that, at least for my M1 MacBook, there's a couple of gems that needed to be updated. It might be fine now because I've actually committed those changes to the gem file, but if any of these commands do give you a problem, these two commands right in this part of the README should resolve that for you. And that's really should be it. At this point now, I can run the Rails server and this will refresh and we've got our login page, and I can click on the sign up button. It'll take me to a sign up page. I could log in and do some playing around with this, but mainly just want to make sure that we can actually load the page. So this is, if you've made it this far, then really everything else should work pretty seamlessly here. And in the log, in the terminal below, you'll actually see the full debug log happening as we kind of navigate this application. So that's again another way that you know that everything's working and we're ready to continue from here. So the next thing we're going to do is I want to run all of the tests that we have here, and just to mainly give you an example of if you wanted to play around and hack on this project some more, and you wanted to find and fix some of these vulnerabilities on your own, these tests are a great way for you to learn how to do that. I'm going to actually run a larger suite. There's some commands down here that you'll see that you can run the Rails training command that will kick off all of these tests. But what we're going to do is actually run these tests with the Rails maintainer environment variable. And this essentially does kind of an inverse of these tests. The idea here is that now all of these tests will actually pass, or largely they will not fail. If you ran this test suite without this environment variable, all of the tests would pass. And that's what I was saying before. I mentioned that the idea is you go and fix these issues and then the test pass after. And we'll show you an example of that because we're gonna find and fix one of these issues in this project along the way. So the main thing is we just want to make sure that there's no failures. You'll see some of these errors kick off there. This is just related to the tests actually running from here. So no issue there. But again, mainly we just want to make sure, can we run the tests? Because this is going to be how AppMap actually generates the maps. How it sees the code running is via either these tests or when we start interacting with the application, which will do both of those things. So from here, now I want to install AppMap into my code editor into this project. And to do that, if you're in VS Code, you can go to the extensions page here, and you can just search for AppMap. It'll show up in your list. I've already got AppMap installed, so I don't need to install it, but there'll just be a little install button here that will let this add it to your VS Code extension. And you'll actually see it show up in your left-hand bar so that it's ready to go and ready for you to start getting it installed in your project. So when we get AppMap installed into here, there's a couple of ways to install it. We can click on this button, which will just kick off our automated installer. This is what I'm going to do here to show you how that process works. But you could also just, again, add the library right to your gem file as well. Most importantly, making sure it's the first gem listed, because if we as an AppMap are loaded first in the gem list, then we're going to see all the other gems executing after the fact. So I'm just going to take the defaults for the installer. And again, what this is doing is adding me to my gem file. It's doing a bundle install to make sure that it works. It's dropping a configuration file, a default configuration file in place. And then at the end of this, it's going to prompt me to commit these to this repository. And now this is really helpful. So if I'm collaborating with other engineers on my team, I can commit all these files to my project. And so when I push these up, when other users clone this project and want to work on it, they don't have to install AppMap. It's all right there and it's ready to use in their project and ready to start generating maps. And so that's it. It's, like I said, very easy to install. If I now go back to my gem file, you'll see the addition of AppMap right here. It's, again, before the Rails gem, it's the first gem. That's where we want it. And you'll also see the creation of an AppMap configuration file. Where is it? Right here. And again, pretty simple configuration file, and this will help us generate our maps. So I'm going to go ahead and close this terminal since I'm done with that. And from here now, it's basically waiting for maps to be created. So, we've got right here, there's no app maps in this project yet. There's a couple of ways to generate app maps, and we're going to show a couple of them here today. One of them is just running the application. So we ran it before with our bundle exec command. We're just going to rerun that command. And you'll see a new debug line getting spit out to the console, basically letting you know that remote recording and request recording is enabled. And what happens there is if I now open up my project and give it a refresh, I will get a AppMap presented to me into my code editor. Really just that simple. And this is showing what happens, what packages are used, what classes are being called, what functions within those classes are being called as part of a login API call, right? I refreshed the login page. And so that's where it took us. And we can then follow this code all the way down to the database, right? So what database queries are involved in just loading the login page? There are some of these queries here and we can dive into them. So you get a couple of different views with your app map. This is the dependency view, being able to understand kind of what is dependent on what, the flow of the data that's happening in this view. And then we also have a trace view, which is probably closer to a stack trace type of view where you can navigate through each of these different functions and classes, being able to see the data that we're sending around to each of these classes, the responses that are happening. And you'll even see these timers. This is all happening locally, but these timers are really helpful to understand different slow paths that might exist in the code base. So from here, that's one way to record our maps. The other way to record our maps is by running our tests. So same thing, I'm going to go back, I'm going to rerun the test suite again. And same scenario is going to happen is we'll get recording enabled by default for these tests. And you'll start to see these requests show up under a different collection. This is under the test section down here. And we'll get one app map for every test that executes. And so each of these will get streamed to us. We don't have to wait. We can actually start interacting with these if we want to while the tests are running, and be able to understand kind of what's happening as part of each of these tests. Now, again, these are all the tests that are related to not only the vulnerabilities that you can go fix, but also they have some other tests here that are just normal, make sure the functionality of the website doesn't break, which is why I'm actually running this larger set of tests. I just want kind of more maps to be able to show off for everyone here. So on the left-hand side, like I mentioned, we've got now maps from a variety of sources. We've got the requests. So for every API, which we'll actually do another test. I'll show you how to generate more of those requests kind of towards the end. And we'll have our spec tests as well. And so from here, we can kind of continue on through the onboarding, and we'll get taken to a page where we can start exploring some of these maps. If maybe we wanted to search for maps based on specific API calls. So I want to see anywhere that the dashboard home API call is part of, right? It'll take me to a list of maps that I could then open up each one of these and be able to understand kind of the path of code from API down to the database and back again. Same thing on the query side. We can see, different queries that maybe we care about more than others. Same thing. Those are all visible down in the code objects view. And if I wanted to see where I used certain queries, I could click into any of those. Same scenario. We get a whole list of every map that query was seen in. And then just some selected app maps, places maybe there's a lot of functions being used, a lot of SQL queries being called, and things like that. All righty. So from here, you'll also notice, we drop this down in our runtime analysis view. This is where AppMap, because we see this code execute, in our code editor here, we can now see the paths that the code is taking, and we can run our analyses on this code base to be able to understand what types of issues we're finding here. And there's a few different issues, some deprecated cryptographic algorithms that we might want to resolve. It'll take us to the specific lines where that is. And then there's this other one here, execution of untrusted system command, right? That does not sound particularly good. We might want to look into that. And this is the scenario that we're actually going to dive into today on not only finding this problem, but then fixing it and using AppMap to help you understand the impact of that fix, because any code change is going to change, how people interact with it. What's great is that when you do see these findings in AppMap, we do provide a link to the CWE page. So if you didn't really understand what this problem even is, maybe hadn't seen it before, you can learn some more information about that. And then it'll take you to the full stack trace as well. So this is where we can, again, learn more about this particular problem and dive into it, as well as the map as well. And so from here, I'm actually going to open a couple of things. We're going to go first to the stack trace. So this is the kind of relevant code where this issue is happening. I'm going to just clear a couple of these out of here. And you'll notice some AppMap pins that will exist on each of these functions. And this will be important later because we're going to show you what these pins really represent is we see this code, this function, we see this function being called in a map that you have. So what this is telling us is that this code is used in a particular place. It'll show us here not only that on this line here, the little squiggle is telling us here is where the problem is that this kernel system runs a untrusted command string. We can actually see it right here, right? Because we're just running a command. That's not necessarily good. If it's untrusted data, which it is, then an attacker could change this data to have it do whatever they want it to do and maybe take over the machine here. But then also it'll take us right to the AppMap itself. So I can go to this AppMap and it'll take us into this trace view where we're actually calling this data and what the data is. This was the data sent as part of the test, what this data is as part of this call. And then we can walk it back and see, okay, well, this is called by the silence streams function, which was called by make backup, which was called by benefits. And that's largely what we see in our code view. We can kind of walk our way back up, which is the save function calls make backup, and make backup takes that data and runs this command while calling the silent streams. And so that's where our issue kind of lies here. So now that we know where the issue is, we can go and fix this issue. So what I'm going to do is actually use a common tool in Ruby software engineering called Guard. And this is something that actually AppMap has some integration with so that I can run just the tests that are affected by this code change. So we ran all these tests. It took 30 seconds. Maybe you have a huge test suite and your test suite takes 30 minutes to run. If you make some changes to the code, you want to be able to run just the specific test that's affected by it. And that's something that AppMap can help with. So we're going to run Guard. And this is just going to kick us out and basically just say, hey, we're watching your project for any changes. And so from here, we're going to go and we're going to fix this issue. So I'm going to this is the problem. The problem is that we should just use standard libraries if we're going to copy files and not actually call a command specifically. So I'm going to just save this file. This has been saved now. And you'll notice over on the left-hand side, the AppMap that was created that this code runs inside of is now marked as out of date. And so this means that like we have changed this code. The map is no longer accurate to the most recent version of the code. But we can use that information to now run the test for this specific code path. And I can open the command palette. So this is actually in, this is a Command Shift P in VS Code. You can also open it via the menu bar at the top. The command palette's very powerful in VS Code. If you haven't spent much time with it, I highly recommend it because you can run a lot of helpful commands just directly from this command palette. And for this, we're going to run a command for AppMap, which is touching our out-of-date test files. And by doing that, you'll actually see down here the RSpec test running for just this particular AppMap. Now, in this test, I'm actually running it without any special environment variables because I want to run it in our training mode. Because what I want to do is I want this test to succeed if I have fixed the problem. And you'll see down here that instead of waiting 30 seconds for all the tests, I ran just the one test in 7 seconds. You can imagine with a larger test suite that saves quite a bit of time. And we have one example, no failures, right? So we have fixed this issue. And I think it even might kick out a passed somewhere. And that's great, right? So we have fixed this issue, we can be done. But there is more that we can do with AppMap to understand kind of the impact. And we can also spend a little bit time to show you how this, the pins have changed, right? So not only did this function now has no more pin, that means AppMap hasn't seen it. It doesn't see it in this code path. And it makes sense, right? Because we just removed the line that actually called that function. And if we now go back to this map again, and we open up this event, you'll see it looks a little bit different than before, right? Before we had benefit save and make backup and silence streams and everything else. You know, obviously we're not following that code path anymore. This map is now updated for the you know, for the latest kind of code path from here.
Can I ask you a question?
Oh, sure. Yeah, please.
Yeah. Can you diff maps?
Yes, no, that's a great question. So one of the things that I'll show you is actually the sequence diagram. So with this particular map that we're dealing with, we can generate a sequence diagram. And this is actually, I want to load it in this page. So let me go back to here.
So I will to save the previous map and then compare with this map.
Yeah, so what I'm actually going to do is I'm going to do, I'll do that with a sequence diagram because it looks a little bit better from the functions getting created. But you know, here's the example of the actual calls here that we're making in the sequence diagram. And so what I'll actually do in a couple of steps here is generate, put the code back, generate a map, a baseline map, and then compare it with a code change. And you'll actually see that kind of diff show up there.
Cool, brilliant. Okay, cool. All right.
Yeah, great question though. I love it. Yeah. So anyway, that was our sequence test. That was another example. So, and again, the sequence diagram, this is getting generated just automatically from this map. You know, you don't have to create the sequence diagrams by hand, and you can expand out or include or exclude any particular functions within the sequence diagram. And you can now push this diagram to like a GitHub pull request, speed up your code review process because you can you know, better understand how the code is actually working. And so, yeah, to that great question, which is, what if I want to diff the before and the after in a visual way? And so that's what we're going to do now. So I'm going to undo my code change back to here. And again, my test is now out of date because I've put that past, and I'm going to touch the out of date test file. So basically kind of set us back to where we were before. Let that test run. And then what I'm going to do with the updated map is I'm actually going to save this as a baseline. So this is a map that, again, this will fail. Perfect, right? That's what we want. And again, the finding has come back. The analysis has completed. And I'm going to save this map to a collection. And I've already created a collection called baseline, but these are just you kind of functional ways to group your maps together, you know, in a kind of a grouping area like this. So this is our baseline map. It's really just a copy of the original.
Another question, and this say,
sure,
what format is that? JSON, is that screenshot, or is that format that you say?
Yeah, so the maps themselves are JSON. these follow the AppMap spec. So in the temp, let's see if I can get to it. Oops, sorry, in the temp folder. So under temp, there'll be an AppMap folder that gets created. And so for our RSpec test, for example, this is where you'll find all of your map data. Now, when you open one of these JSONs, if I open one that actually has data in it, when you open one of these JSONs in your VS Code, we'll seed it and obviously represent it as a map itself. But they are, if I open them with just like a finder here, you can see here, it's just, it's basically follows the AppMap data spec, and just returns it as JSON. So this is kind of where some of the extensibility comes, because this is a raw data set essentially that you could use in other tools and areas, which I'll actually show you as well with some of our open API generation.
Yeah, that's also because that was the thing. Because then you can always just consume them directly, right?
Yeah, exactly. Yeah, exactly. Yeah,
Cool.
yeah. You've got it. You've got it spot on. All righty. So I've got like I said, I got our baseline, and this is just a copy of the map. This is going to stay essentially unedited as we change our code. And so now I can go back and I'm going to implement this change again. But I'm actually going to simplify it even more, because as I look at this code, the save function is going to call make backup, which then just calls this other function with our command. And I can just simplify this entirely, which is what I'm going to do. So I'm going to comment out this line. I'm going to grab this, and just put it right here. And so I'm going to save this file. And when I save with the updated code,
can I make a little feature request, which is actually something
sure.
I always wanted to have, and I think you guys are quite close. It'd be really cool, the same way that you see that thing on the right, like little visualization of the code structure. No, on the right.
Yeah.
The little the little code navigation that VS Code puts in, right around the top right. You see the top right?
Oh yeah, this little thing. Yeah.
What I think would be really awesome would be to start to show that visualization of the code. And basically what you're doing is you're showing the graph of the code. So as I modify the code, even if you're a couple of seconds behind, it will make a massive difference to start to see the shape, right? And because one of the things I always found that would be really cool is that you're coding away and suddenly you create a vulnerability. It's almost like on the right of your screen, something goes red, right? Or something, you have a very small graph that goes massive because, for example, you just connected something, you just need something that has a huge amount of security implications. So it would be really cool as you're making these code changes, right? It's almost like a test, right? Like to be able to see the graphical representation, which you already have, and it probably computational wouldn't be that expensive because you only need to calculate the diffs, right? You can optimize
just the diff of the changes. Yeah, exactly.
Yeah. But it will make a massive difference because the same way that the reason that it's on the right is so popular is you can see the structure, right? If you don't get a sense of structure, but if you can then start to have a visualization of parts of the structure, for example, which bits are connected to the outside world, what's the thing, etc. Even just the shape of the graph would tell you well architectural patterns versus bad architectural patterns. And also as you fix things, you can start to say, well, this is what it's supposed to look like, right? This is the pattern that I'm looking for, right? And then ideally you can even color code some of it. But I think, I think you have a little really powerful thing that you're not that far off, which is to be able to provide visual representations of what you're actually making the code changes, which will actually help a lot when processing and even making the changes, right? With confidence.
Yeah. No, I love that. Yeah, absolutely. It's kind of where sequence diagrams came from. It's like that idea that we've got a couple of visualizations based on this raw data. A sequence diagram is just like kind of another way of visualizing this information, and trying to going back to our code review process, trying to just speed that process along, because you can now visually understand it. So yeah, I love that idea. That's great. So yeah, I've got our code change here, and we're just going to simplify entirely. We're going to basically cut out these two functions here, which means now both of these maps are going to be out of date, which makes sense because we made that change. So we'll go ahead and touch these test files again, which will rerun to update our maps. And you'll notice a little slight different change than last time, which is these pins will actually stick around. The map will update, and our test succeeds. But the pins will stay, and also the finding will stay. And that's basically because we still have a map in our local here, that where the code actually executes, and being able to go there. This function, for example, will actually exist in multiple maps, the baseline and the other one. But now we have a diff, right? We have an old version and a new version of that one. And so from here, I can go to my baseline and I can compare our sequence diagrams now to really any of the other maps. And now I can collect. So I've got at the top here, this is my baseline collection. I'll go to the RSpec test, and you could even do this on similar maps. Maybe they're not exactly the same code path, but they're close, and you want to understand the sequence difference between like user A interaction and user B interaction. But in this scenario, I'm just going to actually compare these two specific changes, right? And you'll see right down here is now we have, again, that same upload action happening, but instead of the make backup and silent streams functions getting used, these are now marked as deleted, and we still return back a string and a 302 message back to the user.
Cool. So, and so another question, do you have a way to navigate this as like a mini website? So, for example, like if you think about it, you're using the UI to find things, right? But you already have all the source files. So, so it'll be, again, it would be really cool to actually start to create a mini website that you can navigate, for example, in HTML, right? That actually allows you, it's a bit like the docs, the Java docs and the Houdini docs, the docs that get created. In a way, you should be able to create that mini version of the website so I can navigate like you just did now, but almost as a separate website, which also could eventually be published. Because think about it, this stuff would be amazing to be published as almost documentation or a repository website.
Totally. Yeah. So there's
right?
Yeah.
Unless
so
you already
with
have it,
yeah, so with AppMap, there is some, this is in some of the SaaS services around being able to share this map, whether it's, sharing this into like a pull request. This will generate a secret URL that you can use to navigate on the website. On the website of the thing, whether it's to share or to collaborate or something like that. The sequence diagrams is definitely newer. We don't have that on the sharing side, but you're definitely right, which is, code changes so quickly that having documentation exist based on the actual runtime of the code makes sure that the developers don't have to continually update it, but it keeps the documentation up to date as the code changes. And it's a perfect segue into the last area I wanted to talk about, which was open API documentation. And so this is kind of another example of how we can use this raw AppMap data in order to kind of inform other tools and give us additional ways of representing this data. And so for those that don't know, open API documentation, it's formerly known as Swagger Docs. This is a way of documenting your APIs to share with other people that might be interacting with your APIs, so they know how to kind of build for your APIs. And you can do it without having to share your code itself, because you can just share the definitions, and the definitions. So in this example, we've seen 63 different HTTP requests, based on the tests that we've run. So imagine a world where you have tests for all your APIs, which you hopefully should. You can now, with AppMap, capture that data and then export it into a format that is now exportable into other areas. So for example, you could actually import this data into Postman as a collection if you wanted to interact with specific endpoints. What we're actually going to do here is we're going to import this into Zap, OWASP Zap project, to be able to run a much more targeted and significantly quicker scan with Zap.
So just to this open API, the API of the public endpoints that you discovered.
Yeah, exactly. So these would be like, let's say this particular app was a public application, and I wanted to publish the API endpoints for developers who were building on top of my app. You can kind of see here in the right-hand column, this is essentially the open API output of each of the API endpoints, the type of content you need to send, the parameters, the format of it. So I'm going to just save this file locally. I'm actually going to save it into the public folder here, because I'm going to use Zap to just download that. So again, this could be a scenario where as you're running as you're updating your application, you can actually run AppMap even as part of your CI processes to essentially export this data out. And so keeping, again, your code and your documentation up to date along the way. So we've got this file saved in here. Now I can open up Zap. And this is actually up in the toolbar, so unfortunately you can't see it in my share, but there's an option to import an open API definition from a URL. And so I've got this data already on my URL. It's in my Rails app, but I just put it in the main folder. And same thing, target URL is going to be my Rails app. And so when I hit import, it's going to parse that data and go through and scan my site. And it will do it a lot faster than if you ran kind of an automated spider process where it will just try to go and explore all that data. And you get basically all of this data automatically loaded in. It's already in Zap. It's already flagged if there's any issues it found on the Zap side of things. If you have certain plugins that you kind of wanted to run as part of this, you get those notifications. But the last part that I want to share is that recording that we can do on the request side of things. Each of those queries to these API endpoints now has its own map for each of those. So again, same thing. If I wanted to understand what happens as part of a specific API request, if I post to the users, what is the database query that's associated with that? Are there any runtime analysis that gets scanned as part of this? That all happens. And then on the same side, this is where this code will get instrumented with an AppMap pin, which you'll see on the right-hand side. Let me just clear a couple of these tabs out here. Again, same thing. You'll have these pins now get created so that you'll be able to see like this function. What maps is it in? Well, this is used in these specific maps. Or where is the account settings function being used? It's used in these maps. And if any of those maps are related to our requests, then those will also show up in the list as well for us to be able to kind of better understand, right? So this create command is part of the post users command. And that's that part of that user's controller there. And so again, this is where we can use tools, use essentially the output of this open data model, the AppMap open data model. We can use the output of this data to power some of our other applications and give us a little bit more insight into this data and use it to hopefully speed up some of the other things that we're doing, whether it's using, like I said, Zap to scan for for any externally facing vulnerabilities or anything like that. All righty, so
what languages at the moment you guys support? This is Ruby. What's the languages that you currently can do, for example, this mappings?
Yeah, so right now we support Ruby and Java, JavaScript, and Python. So kind of what I would call the big four, but we're always adding additional languages. And if there are other languages that people are interested in, definitely let us know, because we're always trying to find where people are spending their time in.
Do you understand things like Lambda functions written in Python?
So right now, most of the usage is based on kind of web application frameworks. So if you imagine like a Python Django or Flask application or a Java Spring application, things like that, really essentially kind of unwinding APIs down to databases. But there are definitely ways that I have seen where you have that ability to instrument like a non-web application, but yeah, we're always looking to kind of expand support for what I would call like non-web applications or even like front applications. We get a lot of requests for things like React, for example.
Yeah, and for those apps, can you run this completely from code, or you always need to have the running app with the agent on it, i.e. in a way the instrumentation?
Yeah, so right now the way we operate is essentially from the runtime data, and you can get that runtime data from either your tests running, your your application running. Maybe you're running it in a container or you're running it in your development environment. Just some sort of way that the code actually runs with our library on it. We don't. It's not something where people would run this in like a production environment. mainly because the data that we're recording is at a very, very low level. And it's if it's in production, you'll see everything from like secrets being generated and very low level information that most people don't really want don't really want exposed out there. So this is primarily for kind of local development all the way up through test, dev, UA type of environments.
Okay. What about gluing web services, right? So if you have, for example, the typical now Kubernetes application with tons of containers and stuff running around, how do you glue, the call from one service to another, so you can have almost like an end-to-end flow?
Yeah, exactly. So there's some, I would definitely call it more of an advanced feature where you can essentially run AppMap. And we've got some links to it in our documentation where you can have AppMap running in like a multiple microservices, and you'd see essentially the request out. And so that's something I don't have here because I'm not making external requests. But if I was calling to like an external API outbound, like if I was calling to Stripe for my payment system, or I was calling to this other API, this other microservice, you would see those outbound requests. And then on the flip side, on the other applications map, you'd see that it would be essentially the endpoint in. And it's those API requests that essentially kind of link those communications together.
And then we're able to create a vulnerability that transverses multiple web services.
Ooh, that's kind of interesting. I don't think we've had anyone do that yet, but the kind of beauty of it is that, we're essentially looking at these maps for design patterns. And so, I don't see any reason why that wouldn't be possible. I mean, the beauty of like anything's possible with code. But with the maps being an open spec, and our analysis tool can kind of dive into those. I'm trying to think of like what would be some good kind of cross service. It's like kind of data flow stuff, right?
Yeah, so I'll give you a couple of very good use cases. So for example, you have internal methods that are vulnerable to SQL injection, right? In fact, sometimes you have.
Oh, I might have lost you there. Yeah, I might have lost you. Can you still hear me? But yeah, I think oh, are you back?
Okay, sorry. So for example, you also have web services that provide data, right? So sometimes you have a web service that provides data, or some sense of HR data, whatever the application is, right? And usually those web services internally tend to be unprotected, right? So there's not every business has been able to implement proper authorization. So the interesting question then is, okay, yes, the web service by design are vulnerable, but is there a connection to the outside world? So if I want to make sure that there's no, for example, business logic that leaks data, I need to be able to figure out which external endpoints are actually connected to that service. But that service would never be exposed directly, it would always be indirectly by other things. So connecting the web services is insanely powerful.
Yeah, no, I love that idea because even just in understanding kind of data flow or sensitive data moving around, being able to see data like again, in a simplistic way, a secret being generated in one application being sent to another application and then misused in that application. Again, with the AppMap library included in both sides of that communication, we would largely have the maps for each of those. Continuing work on just like how we tie those together, how we visualize those. Those are all areas that we love to hear these different use cases out there.
Cool. No, brilliant. All right. Sorry. That's for my questions. Keep going.
Yeah, no, appreciate it. Yeah, so I mean, that's pretty much it. We're just at the top of the hour here. Like I said, really appreciate everyone's time. I know we're a little bit short for if there's any other additional questions, but you can always find me if you do have questions, or if you're diving into this project and you wanted to, learn a little bit more about this. We have a AppMap community Slack for the open source community. You can just get to that through appmap.io/Slack. Feel free to join there. You can DM me, or you can join one of the channels in there if you have a language specific question in there. You could also tweet or DM me also at Pete Cheslock on Twitter. My DMs are open, always happy to answer any questions along the way. And then, yeah, I mean, like I said, you can grab AppMap today. Like I said, it's open source, available through the VS Code and JetBrains marketplaces. And, you know, as you're mapping your applications, if you come up with these different use cases, interesting ways to use AppMap, definitely let us know. Drop into the Slack and you can chat with engineers, and we'd love to hear kind of how you're using it. Awesome. Sounds great. Well, like I said, really appreciate the time.
Yeah, no, brilliant. You know, can I just propose as a last idea? So I was just moving to my car now. I think it would be really cool to do a session with users, you know, AppMap users or people who try to use it, and then almost like a forum of where it works, where it doesn't work, success stories and challenges. I think the next question is, where do you start, right? So to have, you know, nice insights of people who have done it, who figure out a couple of use cases. Because in my head, you know, the best way to do this is find 1 or 2 use cases and then just scan it widely and go, okay, we're now using this for that, right? And also try to get it so that, for example, security team uses it, or doing secure reviews, because I think this helps a lot. So maybe for the next summit in February, let's do a couple of sessions on that.
Yeah, sounds great. No, we'd love to keep talking more about like how our users, our early users are using this to, you know, for kind of all parts of their development process, not even just the security side. There's also even just performance issues that people find and fix on the observability side, which is a lot of fun.
So thanks a lot. Another great session. I really think this is one of those up and coming tools that a lot of people should be paying attention to. So good luck and keep the development.
Yeah, thanks so much. Like I said, thanks for having us. And if you do have any questions, find me on the Slack or find me on Twitter, and happy to chat more about it.
Cool. All right. See you guys.